Hello, guys. Okay, so today we are going to continue with differentiation, and our main goal of today is to learn how to differentiate an exponential with the base e raised to some function f of x. So we want to learn about the rules that can be used to differentiate such type of functions, or the logarithm, or the process as to how exactly do you differentiate a function like that one, which is exponential, and the base is specifically base e, not just any real number. So we're going to look later at how to differentiate an exponential whose base is just an arbitrary positive real number. For now, we just want to focus on these type of functions. You see, so to differentiate these type of functions, there is a rule that one can apply, and this rule it goes as follows. It says that the derivative of e to f of x is simply given by f prime of x times e f of x. So these are things that you do not have to memorize, just as I've said. You see, this thing just carries a message that you just have to find it, and then that's it. Or it contains a recipe to say that you just have to analyze, and then boom, you just forget about this. So now what we're going to do is we're going to learn the recipe of how to deal with this. So to demonstrate the recipe, a typical function that we want to look at is something like this. You see, so if y is defined as e to the power 3x minus 1, find dy dx. So you can be given a function like this one, and then they say, can you find dy dx in this particular case? So how do you go about finding dy dx in a problem like this one? So to find dy dx here, this is how you proceed. You see. So dy dx is obtained as follows. So every time when you're given an exponential function whose base is specifically base e, the first thing that you do is when you want to differentiate it, first you look at the power or the index of that base. And then what you do first is you take that index and differentiate it. So when you differentiate it, you apply the rules that you know. So we see that these things are just simple polynomials. So we differentiate them. So we know that when you differentiate 3x, this will just become 3. And if you differentiate -1, it becomes 0. So the only thing that you obtain from your differentiation is just 3. So what you do is you bring that result down. So you write down that 3. So after bringing this result down, the next thing that you do is you bring in the original exponent that you are differentiating as it is and multiply that number, and that becomes your final answer to your problem. You see. So this is how things go. But now let's do another example again so that we can get this into our brain. So another question that we have, it goes as follows. So if f of x is defined as e to 3x 4 plus 5x squared minus 1, find f prime x. So we have that again. We are given that function and we want to find the derivative here. So how do we find the derivative here? So to find the derivative already f prime x, we proceed as follows. So first thing, you take your index of your exponent and then you differentiate it. So your main focus now must just be here. This is where your main focus should be. So what you do is you differentiate that. So you see that when you differentiate the first term, you get 12x cubed, so you bring it down. When you differentiate the next term, you get 10x, you bring it down. Then differentiate -1, you get 0. Once everything is done, you then combine all those and put brackets around it. And then the next thing that you do is you bring in the original function that you were differentiating without making any changes. So there is no subtraction of 1 from the exponent. You just bring it as it is. So you just bring that as it is. So if you want, you can make simplifications, but if you're here also, it's fine, because we can see that 2x is common here. So you can pull it out so that you get 6x squared plus 5, then e to 3x4 plus 5x squared minus 1. So that becomes a solution like that. So this is how you differentiate exponential functions whose base is e. So yeah, that's it. So thanks for watching, guys. See you on our next